Okay, let's have a go at this. Let's just double check it. So that has to be written in that form. So I'm going to say 4 sine x minus 6 cos x is going to be identical to r sine x minus theta. Now the first thing to do is expand this out. So you got r, now this is your addition angles. You'll get sine x cos theta, and in the sine function, in the addition formula, that will stay as a minus, and you will get cos x sine theta. Okay, that's one of the first things we did on addition formulas. Now I'm going to times it out and get the times everything by r, so you'll end up with r sine x cos theta minus r cos x sine theta, and that's going to be the same as what we got on here, 4 sine x minus 6 cos x. Now if we match up all the signs, you'll end up getting 4 sine x equivalent to r sine x cos theta, and if you match up all the causes, you're going to get the minus 6 cos x identical to minus r cos x sine theta. Now the beauty about this is the signs will cancel, so you'll end up with 4 equal to r cos theta, and over here the negatives will cancel and the causes will cancel, and you'll end up with 6 identical to r sine theta. Okay, that's just using our additional formula. Now once you got it in this stage, you can easily pull out the tan, so you can just say, if I do r sine theta shared by r cos theta, or r sine theta is 6, r cos theta is 4, and by doing this the r's will cancel, and you end up with tan theta equals to 6 over 4 is 1.5. So theta will equal tan inverse of 1.5. That will, if you check your calculator, tan inverse of 1.5, you should get 0.983 radians. So you got the angle, I've got that bit, I just need to find what r is. Now you don't need to do r the long way. All you can say is r squared is the same as 4 squared plus 6 squared. You don't need to prove it each time, because these, when you square in it, cos squared plus sine squared becomes 1, so they will go. That's the reason why we do it. So you can just say r squared equals 4 squared plus 6 squared, so r squared equals 16 plus 36, which is 52, so r will equal root 52. So now, why is this helpful? What you've done is you've combined this function here into a singular function in terms of sine, where r is root 52, and sine has been transformed or translated, sorry, by 0.983 radians, shifting it forward, and that is the same as that. They are what we call mathematically equivalent. Now, at the equivalent. So why is it important to do this? What you can now do is you can go about and solving this equation. You know that for sine x minus 6 cos x, okay, is the same as or is identical to 52 root sine x minus 0.983 radians. So when it goes here, hence find the maximum value for the smallest positive value of x, you can easily do that because you know, well, you should know the maximum values of this function. What is the maximum value of a sine? Anybody? 1. And the minimum is? Minus 1. So the maximum value will occur here. So if that was 1, what would be the maximum value of this function? Anybody? Root 52 times 1 will give me? Maximum value will be root 52. And that will occur when sine x minus 0.983 is equal to 1. So you could do this, shift that to the other side. So x minus 0.983 would equal sine inverse of 1, which is 90 or pi over 2. So x would equal, so if I go and do this, if I get shift inverse of 1, I've got pi over 2, then I add 0.983. This will give me 2.554. Now, question is that the smallest angle I'm going to get? Well, that's already gone out at 90, so it can't be the smallest, so I need to double check something here. So it's a good idea is to draw the sine curve. Okay, and see where the 90 is going to go. So when will that give me, when I do the sine inverse, well, actually, yeah, that is going to be the smallest. Yep.